In this mini tutorial, I want to show you some complex ions, talk about their shape and their ligands and the charge of the metal ion and how to figure it out. The first three sets of examples are linear, so you have your metal here and you have two ligands that are making two dative bonds with it. So it's a linear complex ion. First example is copper surrounded by two chlorides. So ligand is chloride in this case. Charge of chloride is 1 minus. It's an anion. So what plus 2 minuses gives you 1 plus. So copper in this case should be 1 plus. And the charge of the complex is 1 minus, what you see as a superscript. The second example is ammonia with silver with two ammonia. Now ammonia is your ligand, it's a molecule, so it has 0 charge. So the charge of the complex is actually charge of the metal as well. 1 plus, 1 plus. The second example is silver again, except this time you have cyanide. Cyanide is -1. So the question is what plus 2 minuses will give you 1 minus. Silver should be 1 plus. Overall you're 1 minus. The second set of examples are square planar. This time you have a flat molecule and you are having 4 coordinate bonds with your ligands. So this is sort of what the picture looks like. That's the shape. The first example is Cu, tetrachloride. So chlorides are your ligands, -1. What plus 4 minuses will give you 2 minus. So in this case, copper should be 2 plus. Overall, your complex is 2 minus. Example 2, you have copper, tetraamine. You have ammonia, which is a neutral molecule. So the charge 2 plus applies to copper as well. 2 plus, 2 plus. Then you have cobalt tetrachloride. Each chloride is -1. The question is what plus 4 minuses will give you 2 plus. In this case, cobalt should be rather 6 plus. And the charge of the complex is 2 plus. Then we go after tetrahedrals. I have 2 examples. This time you have a molecule that is not flat, a complex that is not flat, and it's being surrounded by 4 ligands. The first one is zinc with 4 ammonia. So you have ammonia, which is a 0 charge. And then the 2 plus applies to the metal, so zinc is 2 plus, complex ion is 2 plus. Manganese tetrachloride, so you have 4 chlorides with -1. What plus 4 minuses will give you 2 minus. Manganese should be rather 2 plus here. And overall you're 2 minus. Then we go after octahedral. This time you have a central transition metal and you have 6 attachments and you look spherical and you are known as octahedral as a shape. The first example, your ligands are water molecules, neutral, so the charge 2 plus applies to the metal as well, 2 plus, 2 plus. Then you have iron with 6 cyanide. Cyanide is 1 minus. So what plus 6 minuses will give you 3 minus. Iron should be 3 plus. And case of complex ion is 3 minus. The next one you have chromium, 4 ammonia and 2 chlorides. So you have ammonia, which is neutral, and you have chloride, which is -1. So this is 0 contribution. Chromium plus 2 minuses will give you 1 plus. So what should chromium be? It should be 3 plus as well. And the charge of the complex is 1 plus. So these are examples of some more complex ions and how to figure out oxidation number of the metal ion.